Alright, so here's a program that runs on MCP-12, and this program does division. And I'm gonna go through this program right now. So the first four lines are to initialize a part in memory, a part in memory that's specially used to store the answer. So we're loading A with a number, and that number is 0, and we're storing A in a location called answer, and that location could be anything as long as it does not interfere with this program. So it could be anything above the length of the program. So usually I use 1000. I think for this program I use 1024 or 1026 actually. So that's just making an area in memory just to store the answer. Then the next four lines are loading A with memory X, and X is your first number. So I think I should go over that first. So X is so let me just write it down. When you're doing when you're inputting the numbers, it's gonna be X over Y is equal to answer. So I think it's like quotient or quotient. I don't know. I wasn't paying attention in school, and they're teaching you the names of the parts of the equation. But X is basically the number at the top, and Y is the number at the bottom. So the first thing we're doing is loading A with mem with the top number, so X. So whatever number you want to be at the top, you put in as X, and X is could be any location, just like answer. So I think I use 1024 for X, 1025 for Y, and 1026 for answer. And what these four lines do is making a copy of X. I'm making a copy of X because this copy is good. This copy called fake X, which I'm gonna store under answer, so 1027. So what fake X is that I could change it no matter what and still be sure that my original X is maintained. So just making a copy of X so I could change the fake X. Alright? So that's what these 8 lines do. It's just initializing. And you can see that there's an arrow coming, and this is the main loop. So basically when you're dividing, you're just subtracting. So you're starting with your X, and you're seeing how many times Y could be subtracted from X until 0. And this program does not account for remainders. So if you do like 3 divided by 2, program will go on forever. I could implement a branch if carry somewhere in this loop, but I did not for this program. So let's start the loop. So load A with memory, fake X. So fake X could be anything. Compare number 0. So what from here to here, just put a line. This is just checking if the fake X, the X that we're going to be changing through the rest of the program, is equal to 0. If it is 0, if it's 0, we know that that Y is divisible by X, or X is divisible by Y, and we know that a full 0 remainder division has been computed. And if it's not, it's going to keep looping forever. That's why if you do 3 divided by 2, it'll loop forever. But if you do 3 divided by 3, the fake X will eventually reach 0. And we'll see why it eventually reaches 0. Right here, load A with mem, answer, add 1. So basically what this part does here is, okay, if it passes the branch of equal and the comparing, we know that it could fit in. So the first thing we want to do is increment the answer, so we know that the answer is like more than 1. So we're incrementing the answer that, okay, Y could go into X, but it's not at 0 yet. Okay, then we're going under, and this is just subtracting Y from X. And when we do that, we store it back in fake X, and we jump to the top, and this is the algorithm for division. And I'm going to enter this program into the computer, and I will show you. Alright, so the program is in, and I chose X to be 1024 and Y to be 1025. So this is 1024, and I'm going to put X value of Well, let's see. I'm gonna put 12. So 12 is in 1024, and in 1025, I'm gonna put 4. Okay? So we know that 12 over 4 is, okay, it's some hard math. 3, okay? It's 3. I was just playing. Okay. So we should get 1 1 on the output. And if we don't, that is a bad day. Usually I hold down reset because that's just what I like to do, but I don't have enough hands, so turning the computer into this, and I'm not gonna set it on full auto. I'm just gonna click the button so you could see it execute. Hopefully this thing, I don't know, to be honest. If something seems wrong just based on what I know, but we'll see. Yeah, and keep going. I'm still tapping, but if I get 3 on the output, that will be really cool. I think we're almost there. Oh man, I'm getting tired of this. I should have put on full auto. I should have put it on full auto. Alright, I think, yep, we're here. Yep, we got 3. Do you see the 3? Yep. And just to compare the speed, I'm just gonna put on reset and we're gonna see it go. I should have done this actually. Yep. Let me get 3 on the output. I'm gonna do something more complicated. Put this back into programming mode. I'll be right back. Alright, so instead of 12, I'm gonna put 512. Okay, and I'm gonna divide 512 by 1, 2, 3, 4, 5, 6, 7 by 128. Okay, and we know that is, I don't know. I think it's 4. Yeah, it is 4. Well, yeah, let's just see it run. Should get 4 on the output. We'll see a 4 pop up soon. Oh, I think something's wrong. Let me reset it and let's see if we get 4. Maybe that wasn't 512. We'll just see what happens. Well, I think it was 1024. So we should get 8. Yeah. It was 1024 divided by 128. I got the place value wrong. But yeah, it's 8. It works. And I'll just show you doing 3 divided by 2. Alright, for x, we're gonna put let's do 3. So 3. So 3's in here. And for y, we're gonna do 2. Put in 2. Let's run the program. And we should see no answer. Wait, what? Yeah. Oh, what? Huh. It's halting. Putting answer 0. That's... when I recall from doing it before, it just looped on forever. This time, I don't know why it's halting. That's pretty cool. I'll look into it, but yeah. Halting or going on forever and putting answer 0, basically the same thing. But the division still works, so yeah, that's it.